Okay, lesson 4.2 is on reflections. So go ahead and open up your notes there, and we're going to start off there. So a reflection is another kind of transformation. So it is a transformation that uses a line like a mirror to reflect an image. Okay, line of reflection is that mirror line. Okay, example 1 says graph triangle ABC with vertices of A at 1, 3. So let's go down here. So A is at 1, 3. Make sure we label it. B is at 5, 2. And C is at 2, 1. Okay. Now it wants us to reflect it over the line x equals 3. So to find that line, I'm going to go on the x-axis to where that value is 3. Okay. Well, my x value is also 3 here, and it's also 3 here, and it's also 3 here. So x equals 3 is this vertical line. Okay, and you can think about it as an x equals line is going to go through the x-axis. Okay, it's got to hit the x-axis for it to be an x equals line. Okay, so what I do with these problems, I would think the easiest way to think about this is that my regular A point is 2 to the left. B is 2 to the right. And C is 1 left. Okay, so now to flip those, we want A prime to be 2 to the right, B prime to be 2 to the left. You see I'm just flipping where they were, and C prime to be 1 to the right. Okay, another way that we can think about this is we can go in a horizontal line, and I can count 1, 2. Okay, well then keep going, 1, 2. This is where A prime is going to be at. Okay, same thing with B. Now I'm going to go to the left to get to the line. 1, 2, so then keep going left, 1, 2. Here's where B prime is. And C prime is 1 away, so then go 1 in the other direction. There's C prime. I connect them, and you can see how that is flipped over that line now. Okay, the size and shape has remained the same. Okay, I've just flipped it over that line and mirrored it across. Okay, so basically if I folded it down that graph along the red line, then A and A prime are going to match up and touch, or I kind of joke that they kiss each other, and then B and B prime are going to touch and kiss each other, and C prime will touch and kiss each other. Okay, so now if I go over to part B, okay, I have the same initial triangle, so let's go ahead and graph that again. So A is at 1, 3. B is at 5, 2. And C is at 2, 1. Connect those to make a triangle. Okay, and now this time we are going to do reflect it in the line y equals 1. So I'm going to go to 1 on my y-axis. Okay, and that line has to go through the y-axis this time because it's y equals, so it's going to go horizontally right there. Okay, so A is 2 up, B is 1 up, and C is on the line. So then to reflect it, I want A prime to be 2 down, B prime to be 1 down, and C prime is still going to be on the line. Okay, so C prime still is right there. So I'm just going to label it C prime again. So A, I count down 1, 2, 1, 2. Label it A prime. B prime is there. Okay, and then there is our reflection. Okay, again, you can tell that, you can really tell on this one that if we folded it along, the shapes would match up to each other. Again, the size and shape of that triangle did not change. It just flipped right over that line. Okay, and that's another thing, I just said flip. So I talked about how translation is like a slide, right? Well, if I have the word reflection, you can see the FL there tells me that it is a flip. Okay, so that's the way that you remember that. Okay, so you can go ahead and turn the page then in your notes. Okay, so example 2, it says graph segment FG with endpoints of F at -1, 2. -1, 2 is F, and G is at 1, 2. Okay, and its image after a reflection in the line y equals x. So if you remember from algebra, y equals x is this line that goes through every perfect corner in our graph. It goes back down this way. Okay, so I go down 1 to get to this. Hold on, sorry, I'm gonna have to think about this. Okay, no, sorry. The way that I teach this one is I count diagonally. Okay, so I go, basically G is a half a unit away. So if I go diagonal, it's half of that box, because if I went the whole box, then it would be 1 whole unit. Okay, so it's half a unit away. So then I want G prime to be a half a unit going the other way. So it would be G prime. And F is 1.5 units away. So then I go a half and then 1 more whole unit. And that would leave me F prime right there. Okay. So that would be that reflection. Okay, now you're probably like, well, Ms. Zickery, that was not very clear of if I'm going diagonal. Like, it's not very easy to maybe see or count how many lines you're away whenever you're counting in a diagonal direction like that. So there's this beautiful table or chart right here, a keynote. Okay, I would, if I was you, put a big star over here by the side, because you're going to want to find this very quickly and easily when you are doing your homework and everything like that. So whenever you are allowed to use it. So basically this is telling you if you started off with AB and you reflect it in the x-axis, your point is going to become A negative B. So all you're going to do is whatever x, y value you have, you're going to change the sign on the y value. So if it was positive, it's going to become negative. If it was negative, it's going to become positive. Okay, same thing with the y-axis. Okay, but this time if the x value, we're changing the value or the sign of the x value. So if the x value was positive, it's going to become negative. If it was negative, it's going to become positive. Okay. And then we have, if we reflect it in the line y equals x, okay, then it says, then we make it BA. So that means that we switched that the order it was in. Whatever was my x value is going to become my y value. Whatever was my y value is going to become my x value. And lastly, in the line y equals negative x, okay, not only are you going to flip-flop the order of your x and y, but you're also going to change the sign, okay? So whatever it is, you're just going to do the opposite of it, okay? So now using that, let's do example 3. So we are going to reflect it in the line y equals negative x. Okay, so the line y equals negative x tells me that I'm going to start with AB, but then it needs to become negative b, negative a. Okay, so what I am taking from example 2 is that f is at negative 1, 2, and g is at 1, 2. So now if I, let's go ahead and graph those first. So f is at negative 1, 2, and g is at 1, 2. So then I am going to, oops, I didn't connect it to make a segment. Okay, now I'm going to apply this rule, okay, to those points. So I'm going to flip the order and change the sign. So that means that f prime is going to become negative 2 and positive 1. And g is going to become negative 2, negative 1. Okay, so negative 2, positive 1 is f prime. And g prime is at negative 2, negative 1. Okay, now if I want to double check my work here, I can draw in, again, I need to connect that to make it a segment. Double check your work here. It's in the line y equals negative x. So that line goes down whenever you're moving from left to right. Okay, because it has a negative slope, negative 1 slope. Okay, and now if I look, yep, that does look like it has been reflected over that line. So I did it correctly. Okay, let me see here. Next page then of notes, we need to keep going. Okay, a glide reflection is what we're going to do next. So a glide reflection is kind of what it sounds like. So it's a transformation that is both a translation. Okay, notice I put a number 1 there first. And then followed by, and 2, reflection. Okay, so first you translate, then you reflect. It has to go in that order for it to truly be a glide reflection. So glide comes first, and whenever I hear the word glide, I think of slide, and whenever I think slide, I should think translation. Okay, reflect is obviously a reflection or a flip. Okay, so example 4, we are going to do graph triangle ABC with vertices of A at 3, 2. B is at 6, 3. And C is at 7, 1. Okay, and its image after the glide reflection. So this rule right here for the translation is telling me that I am going to go left 12. Okay, so I go left 12. And I am actually going to leave my y value right where it is because there's nothing there. Okay, so you can also think about it as subtracting 12 from every x value. So if that's the case, then my a prime is going to be at negative 9, 2. B prime is going to be at negative 6, 3. And C prime is at negative 5, 1. Okay, so I'm just going to slide it 12 units to the left. So negative 9, positive 2. It's A prime. B prime is at negative 6, positive 3. And C prime is at negative 5, positive 1. Okay, so I just slid it over. It's still the same size, same shape, just moved over. Then we are going to reflect it in the y-axis. Okay, so, oh, sorry, not the y-axis. I read that wrong. X-axis. So here is my x-axis. Okay, I'm making it thicker so that we can really see what I'm reflecting over. Okay, then we are going to flip it over that. So whenever we do the x-axis, if we want to go back for our rules, x-axis is a, negative b. A, negative B. So I'm going to switch the sign on all of my y values. So A double prime becomes -9, -2. B double prime is -6, -3. And C double prime is at -5, -1. Okay, and you can see how this works out here. We go here. Okay, or you can use my old method for X and Y axis of how I counted. That's a pretty simple method to use for that, but we also have this rule that we can use, so it's helpful to see how both of those work. Okay, again, nothing has changed with the size or shape, we just flipped it over. Do note though that I didn't come back to my original and flip it over. Okay, remember for composition of transformations, we always start where we left off. So I started here, I moved it here, okay, well then I have to start here and flip it over there, okay, and that's how that works. Okay, so then line symmetry is a figure has line symmetry, I'm not going to write it again, when it can be mapped onto itself by a reflection in a line. Okay, the line of symmetry then is that line of reflection. Okay, and kind of a note here, a figure can have more than one line of symmetry. Okay, so it can have more than one. All right, so there we go. Here it says how many lines of symmetry does each figure have? Okay, well this figure has one going up and down and one going side to side. So that would be a total of 2. Okay, B, and all of these are hexagons, note, because they have 6 sides. So B has one here. If I turn it, one there. Turn it this way, it has one going through here. Okay, now it also has a line of symmetry going through every set of corners as well. So it has a total of 6 lines of symmetry. Okay, and the last one, the only way that I can fold this onto itself is side to side. So it just has 1. Okay, and I think that's where we end our notes. Yep, so the next one is rotation, so we'll do that one next.